All right, in the last episode, we learned how to use oxidation numbers to predict if a reaction is a redox or not. Basically, we look at changes in the oxidation numbers for any element before and after the reaction. If there is a change, it is a redox reaction. If there isn't, it is a non-redox reaction. This was the example reaction we worked on. In this example, calcium oxidation number for calcium changed before and after the reaction. Oxidation number for chlorine changed before and after the reaction. So this is a redox reaction. That was what we learned last time. Today, we continue to work on the redox reaction. We're going to learn a few terminologies related to redox reaction. Now today, we're going to use this reaction again to go over some terminologies related to a redox reaction. So let's label the oxidation numbers on this reaction, on all the reactions in this reaction again. Calcium changed from 0 to 2 plus 2. Chlorine changed from 0 to -1. So let's look at calcium only. Clearly, the oxidation number increased. So the oxidation number for calcium increased in this case. Well, what happened to the electrons of calcium in this case? At the beginning, calcium was by itself. After the reaction, it combined with a nonmetal. It carries a 2 plus charge, actually. We know calcium lost electrons. How many did it lose? It changed from 0 to +2. So it lost 2 electrons. We know when an oxidation number of an element increases, it tells you that that element in the reaction lost electrons. So here we go. When an element or a reactant loses one or more electrons, we say that substance is oxidized. Oxidized will result in an increase in oxidation number. We also say that an oxidation reaction occurred to that substance. All right, so in this reaction, we can say an oxidation reaction happened to calcium. We can also claim calcium is oxidized. Now, if we focus on chlorine, what happened to chlorine? Chlorine's oxidation number decreased. The oxidation number of chlorine decreased from 0 to -1. It gained electrons. How many? Well, chlorine changed from 0 to -1. So each chlorine gained 1 electron. But there are 2 chlorines involved in this reaction. So it gained 2 times 1 electron. It actually gained 2 electrons. As you can see, the electrons lost from calcium is the same from the electrons gained by the 2 chlorine atoms. Well, if a substance, a reactant, gains 1 or more electrons in a reaction, we say it is reduced. The oxidation number decreases. Reduce means decreases. We say a reduction reaction happened to that substance. So specifically in this reaction, we say chlorine is reduced. A reduction reaction happened to chlorine. Then let me ask you guys another question. We just clarified that calcium is said to be oxidized. Now my question is, who is oxidizing calcium? If I tell you guys I am hit, then there must be someone who is hitting me. So if we say calcium is oxidized, who is oxidizing it? If calcium is losing electrons, who is taking electrons away from calcium? Chlorine, of course. So the one that is reduced, chlorine, the one that is reduced is called the oxidizing agent. The one that is oxidized, for the same reason, it is called a reducing agent. From this reaction, from this example, we can see that in the reaction, if something is reduced, there must be something else that is oxidized. There's no oxidation without reduction. There's no reduction without oxidation. Does that make sense to you? So therefore, oxidation and reduction always happen simultaneously. There isn't oxidation without a reduction. There isn't reduction without oxidation. Well, this slide is trying to use two charts. Both charts are from our textbook. So it is trying to use two charts to tell us the relationship between the oxidation numbers and the oxidation reduction, the loss or gain of electrons, reducing agent, oxidizing agent, something's reduced or oxidized. Well, they will work for sure, but I did summarize all of this together by using some phrases. So increase in oxidation number, if the oxidation number of a substance is increased during the reaction, it means that substance has lost electron or electrons. We say it is oxidized. We say an oxidation reaction occurred. We know it is a reducing agent. And also, decreasing oxidation number means the gain of electron or electrons. It is reduced, a reduction reaction occurs to it. It is an oxidizing agent. All right, practice. Which of the following are redox reactions? Identify the oxidizing and reducing agent if it is a redox reaction. Zinc plus hydrogen chloride produces zinc chloride and hydrogen. Oh, we knew this. We know this is a redox reaction because at the end of the last episode, we concluded that single replacement reaction is a redox reaction. So this is a redox. Our goal now is to predict which one is the oxidizing, which one is the reducing agent. So let's label the oxidation numbers again. Zinc went from 0 to +2. Oxidation number increased. When it is increased, we say it is oxidized. The one that is oxidized is the reducing agent. So zinc is the reducing agent. Then HCl, inside HCl, hydrogen changes from +1 to 0 in this case. So hydrogen, the oxidation number of hydrogen is decreased. We may claim hydrogen in HCl is the oxidizing agent. Well, usually what we do is that we do not claim an element in a substance that we do not call it an agent. We call the whole thing as an agent. So HCl is an oxidizing agent. It is absolutely correct if you want to say it is the hydrogen in HCl that is working as an oxidizing agent. That is absolutely correct. However, again, we claim the whole substance as an oxidizing or reducing agent. Oh, so right here, zinc reducing agent, HCl oxidizing agent. B, wow, dichromate, hydroxide. All right, well, let's work on this. Oxidation numbers, we have chromium, oxygen, and hydrogen, 3 elements involved in this reaction. So oxygen, here, here, and here, and here. None of these oxygens is in peroxide. So they're not in the peroxide. If hydrogen is not in peroxide, but they're in the compounds, then we know they are all -2. Oxygen is -2 unless they're in a peroxide. So the oxidation number of hydrogen didn't change. Well, let's look at hydrogen then. Oxygen didn't change. What about hydrogen? Hydrogen here, if it is in a compound, if it is in something covalent bonded with some other element, hydrogen is +1. Before the reaction, hydrogen is +1. After the reaction, again +1. Hydrogen didn't change. There are only 3 elements involved. Okay, let's look at the chromium. Before the reaction, let's try to figure out what is the oxidation number of chromium before the reaction. There are 2 chromium, 2 times whatever the oxidation number is from chromium, we don't know yet. So 2 times that oxidation number plus 7 times, there's 7 oxygen, each one is -2, plus 7 times -2 is going to equal the charge of the polyatomic ion, which is -2. If you solve this equation, you're going to figure out the question mark here, the oxidation number of chromium here before the reaction, it is going to be +6. Let's do the same thing here. What do we have here? We have an oxidation number after the reaction, oxidation number of chromium. We don't know what it is. Plus, we have 4 oxygen. Each one is -2. All adds together is going to equal the charge of polyatomic ion, which is -2 again here. If you do this equation, solve it, you're going to realize that the oxidation number of chromium is 6 again. So it's also +6 here. The oxidation number for chromium didn't change. So there is no change in oxidation number for any element in this reaction. This is a non-redox reaction. This number 2, B, is not a redox reaction. C, well, C is unique. We have to rewrite out this reaction to make it easier for us to discuss. So we have 2 CuCl reacted. There are 2 of these reacted to produce CuCl2 and Cu. Okay, let's look at the oxidation number for chlorine first. Chlorine in the ionic compound, always -1. Chlorine ionic compound, always -1. So -1, -1, -1. The oxidation number for chlorine didn't change. Let's look at copper. +1. If chlorine is -1, this copper is +1. If chlorine is -1, this copper is +1. So copper, there are 2 different two copper atoms involved in the reaction. Each one of them is +1. In the product, CuCl2, this copper is +2 because there are 2 chloride ions in the formula. This copper is +2. This copper is 0 because it is in its elemental state. So what do we see here? One copper oxidation number increased, changed from +1 to +2. Another copper oxidation number decreased, changed from +1 to 0. So in this case, there are 2 CuCl formulas reacted. One is functioning as an oxidizing agent. The other is functioning as a reducing agent. It does happen in nature. Examples like this is pretty common actually. So in this case, copper 1 chloride acts as the reducing and oxidizing agent. Another practice, same kind of question as the one on the last slide. 5 different reactions. Try to work this out by yourself. Okay. Refer back to the last slide regarding how you should work on this. Once you get your conclusions for all 5 of them, proceed to see the answer key. So please pause the video and do them. Here is the answer key. I hope you got them right. See you next time.